Section 3.4, Comparing Measures of Center. Okay, we want to recall from our prior sections in Chapter 3, what measure of center and spread should we use for symmetric data, and what measure of center and spread should we use for skewed data. So if our data is all basically symmetric, our measure for center is the mean, and our measure for spread is the standard deviation. And if we have skewed data or outliers, remember that also puts us here, then our measure for center, our better measure for center is then the median, and our better measure for spread is the IQR. In a symmetric distribution, the mean and the median are approximately the same. So you can see that in the diagram below, and this is the same diagram that we looked at in our prior sections, that the mean and the median should both be right in the center, basically the same value if you have symmetric data. Now, if you have a right skewed distribution, so this one right here, if you have a right skewed distribution, notice that the mean tends to be higher than the median. So it's those few very high values out here, take that average or that mean and they pull that average up, whereas the median fairly stays put. And then on the other end of that, if you have a left skewed distribution, those small values that are out here will pull that mean down and it will end up being lower than your median. And then just as a reminder, outliers are those data values that may not fit the pattern or are very extreme. Okay, the mean can be greatly impacted by the presence of outliers. So again, even if your data isn't skewed, just one single value, maybe in this skewed distribution, one single value very far out can pull the mean drastically back and forth, but the median won't as much. So one example is if a student in one of my classes gets a score of 0 on the test, then that score brings the whole class average or mean down greatly. Now the mean doesn't paint a good picture to me of how the class performed in general, and when those cases arise, I absolutely use the median for my average, for my center calculation instead. The median is what we call resistant to outliers. Excuse me, I'm going to try that again. Resistant to outliers. It's not affected by the size of an outlier, and it doesn't even change if a particular outlier is replaced by an even more extreme value. So what I mean by that is, let's say the missing data value here is 9. 9 would not be considered an outlier here. And if we go through and mark off our values to find the median, 4 would be our median. Now, let's say we replace that 9 though, we replace it with something that would be considered an outlier. Let's replace it with the number 50. Notice even though that's an outlier now, it doesn't change what the median is. We still would count from outside in, and we would still arrive at 4 being our median. So you can see how the median doesn't really get pulled back and forth by outliers. However, if we were to have calculated up the average with the 9, that would have been a much lower value than calculating up the average with the 50 included in there. So if you have an outlier present, you really want to stick with the median. It's a better measure of center because it's resistant to those outliers. It doesn't get pulled back and forth. If you are comparing groups and any one group is strongly skewed or has outliers, then it's best to compare the median and the IQR for both groups, or for all groups. So here's an example. We saw these two histograms put together as one in some of our prior sections. Now they've pulled them apart. So now we have our amateur marathon finishing times, and we have our Olympic marathon finishing times. If we want to measure center and spread for each of them separately, which measurements should we use for each data set? Well, if I'm looking at them completely independently of each other, I would look at the amateur graph and probably say that looks fairly symmetric. I don't really see any outliers either. So for the amateur runners, I would use the mean and the standard deviation. And then the Olympic runners, to me this looks right skewed. So on this one I would use the median and IQR. Now that's if I'm looking at them completely independently. If I want to take it a step further and I want to answer a question like, typically which group has the fastest finishing times? What measurement should we use to compare these two groups to one another? So if we're going to compare them to one another now, not independently, but compare them with each other, what I'd want to do is follow my rule up here. If you're comparing groups, and if one of them is skewed or has outliers, you should just use the median and the IQR. So because the Olympic set is skewed, here I would use the median and the IQR.